Let's be honest, reading data in Next.js is easy, but the moment your UI needs to change something, a mutation, everything gets complicated fast. Remember the API route dance? You create a separate file, write a fetch call, manually stringify JSON, set up headers, and then track is loading and is saving states just to keep the UI in sync. It's a massive amount of plumbing for a single add post button. In this guide, we are moving beyond simple components and killing the boilerplate with Next.js server actions. We are shifting the mental model from I need an endpoint to I need to run a server-side function when this user clicks a button. It's a cleaner, it's a type-safe, and it's programmatically enhanced by default. We aren't building a toy demo. We are building a real-world posts feature with full CRUD. Create, edit, and delete. You will learn how to handle form data like a pro, implement server-side validation with sort, and use useActionState to show real-time error feedback without rewriting your entire app. If you are tired of burning every button into a mini backend project, this is for you. Before we touch any fancy feature, I want to name the real problem this tutorial is about. It's not forms. It's not server actions. The real problem is that the moment your UI needs to change data, everything gets complicated really quickly. In React and Next.js, reading data is usually straightforward, but a mutation means we are changing something, creating a post, updating a profile, deleting a comment, liking a video, anything that changes the state on the server and then needs to be reflected back in the UI. So, in this course, we will build a tiny posts feature set together. Not a toy button that logs to the console, but the real set of things you end up needing. Create, edit, delete, plus a form experience that still feels good on slow networks, and a UI that actually stays in sync after the server changes. To make that pain feel real, let's start with a super small demo that we can run immediately. I'm going to open app/page.js and I just want the page to render one component. First, I will import the component I want to render. Import posts demo from posts/demo. Now, I will write the page function signature first. Then we will fill it in. Export default function page. Inside, I will return a main tag first. And inside that main, I will render posts demo. Now, let's create that file. app/posts/demo.js. Since this component will use state and event handlers, it needs to be a client component. So, I will start with the directive useClient. Next, I will write the component function signature first. Export default function posts demo. Inside this component, I want two pieces of state. One for the current input text and one for the list of posts. So, first, I will create the title state. Const title set title, and I will call the useState function and I will pass the blank string as the default value. Nice. My editor auto-imported it at the top. Now, I will add the post state. I'm going to start with a couple of posts hard-coded, just so we can see a list on screen right away. Now, we need a submit handler. And here's where the mutation part starts showing up, even in a tiny demo. When the user submits, we want to take whatever is in title, create a new post, and put it into the list. I'll write the handler signature first. Const handle submit is equal to I will receive the event and the function body. Before I type this next line, here's why we need it. In the browser, a form submit tries to do a full page navigation. In a React-driven UI, we usually want to intercept that default behavior so we can handle the submission ourselves. So now, I will prevent the default submit behavior. Event.preventDefault. Next, I will create the new post object. I want a unique ID so we can safely render it in a list. Const next post ID. I will use the crypto.randomUUID and the title property. Now, I will update the posts list. I am using the function form of setPosts, so React gives us the previous value reliably. SetPosts, I will get the previous posts, and then I will return a new array with next post and the previous post's predate. And after a successful submit, I will clear the input. So, set title and I will pass the blank string. Cool. Now let's actually render some UI so we can feel what's happening. I will start by returning a section tag. Inside it, I will add a title first. H1 beyond components. Then I will add one short line of context for the learner. what they are looking at. So I will use a p tag, and there I can write, we are going to build a tiny posts feature and use it to understand mutations. Now let's add the form. I will write the opening and closing form tag first. Now I will connect the form submission to our handler using onSubmit. Inside the form, I will add an input first. Now I will give it a name. Even in this tiny demo, I want to keep the mental model of this input represents the post title. Now I will connect it to state. So the input value comes from title. And now we need to update title when the user types. I will add an onChange handler that reads e.target.value and stores it. Now I will add the submit button. I will write the opening and closing tag first. Then I will set type is equal to submit so the form submission flow is clear. And finally, I will add the label, add post. Great. Now I need to render the list of posts. I will add a UL first. Inside, we will map over posts. I will start by writing the opening and closing braces block so it's clear we are rendering an expression. Now I will render an li for each post. First, the li tags. Now I will add the key prop. And inside, I will render the post title. At this point, if we run npm run dev, we should be able to type a title, hit add post, and see it appear instantly. So far, this feels nice. But here's the real reason this section exists. This is a mutation, and we haven't even touched the server yet. If I refresh the page, everything we created disappears because we only mutated client state. And in a real app, we don't just want to update an array in memory. We want to actually create a record on the server and then make sure the UI updates correctly after that server change. That gap between the user did something and the UI stays correct after the server changes is the core problem we are solving in this course. And we are going to solve it in a way that feels natural for forms, reduces moving parts, and keeps the mutation logic close to the UI that triggers it. In the previous section, we built a tiny posts UI and we proved something important. Making the UI look like it created a post is easy, but the moment I refresh the page, everything disappears because we only changed client state. So now we need the traditional solution. We need a server endpoint that can create posts, and we need our UI to call that endpoint. In Next.js App Router, that means our route handler, which is basically an API route living inside the app directory. And before we even write the route, I want the data to live somewhere on the server. I don't want to set up a database in this section because that would hijack the lesson. So we will use a tiny in-memory store module on the server. It's simple, it runs, and it lets us focus on the request response flow. Let's create a file called app/lib/posts-store.js. Now I will create a posts variable. I will start with an empty array first, and I will add 2 initial posts. So our UI has something to render right away. So I will add the first post object, id1, title. Here we can write hello from the server. And I will add the second one, id2, title. This survives refresh. And I can write until the server restarts in the bracket. Next, we need a function to read posts. I will write the function signature first, export function get posts. Inside, I will return the posts array. Now we need a function to create a post. Export function create post, and we will receive the title as parameter. Inside, I will create a new object. I am using crypto.randomUID, so we get a unique ID without extra dependencies. Then I will put the new post at the top of the list. Posts is equal to an array, then post, then the spreaded form of posts. And finally, I will return the created post. Now that we have server-side storage, let's expose it through a route handler. Create a file called app/api/post/route.js. First, I will import the 2 functions from our store module. Import create post, get post from lib/posts-store. Now, I will implement the get handler. I will write the function signature first. Export async function get. Inside, I want to return JSON. Next.js supports response.json. So we will return an object that includes posts. Return response.json posts get posts. Now let's implement the post handler. Export async function post, and we will receive the request object as parameter. Before we type the next line, here's the idea. When the client sends JSON, we need to read that request body on the server and turn it back into a JavaScript object. So now I will read the JSON body. Const body is equal to await request.json. Next, I will create the post using body.title. Const post is equal to create post, and we will pass the body.title here. And I will return the created post back as JSON. Return response.json and the post object. At this point, the server side is ready. Now comes the part that usually surprises people. The UI needs a lot more code now because it has to talk to that endpoint, track pending states, and make sure the list updates. Let's open app/posts-demo.js. First, I'm going to replace the initial post state so it starts as an empty array. Now, I want to show a loading state while we fetch posts. I will add a new piece of state for that. Const is loading, set is loading, use state, and I will pass true as default value. And I also want a state for the saving phase, so we can disable the submit button while the request is in flight. Const is saving, set is saving, and I will call the use state with a default value of false. Now we need a function that fetches the post from our API. I'll write the function signature first. Const fetch posts is equal to async function. Before I type this next line, here's what we are doing. Fetch gives us a response, and we call .json to read the JSON payload. So first, I will call fetch for get on /API/posts. Const response is equal to await fetch /API/posts. Then I will read the JSON data. Const data is equal to await response.json. Now I will store the posts into state. So sets posts, and we will pass data.posts. And once the posts are in, we can turn off the loading flag. So set is loading, we will make it false. Now we need to call fetch posts once when the component mounts. That's what useEffect is for. I will add the useEffect call now, useEffect and the template. Inside, I will call fetch post function. Nice, my editor auto imported it at the top. Cool, now let's adjust the submit handler so it calls our API instead of directly pushing into the array. First, I will make handle submit async so we can await the request. Const handle submit is equal to async, we will receive event as parameter, and we still need to prevent the browser's default form navigation. So I'll write event.prevent default. Now I will set the saving flag to true so the UI can react immediately. Set is saving, and I will pass true. Before we send the request, here's the part that adds more moving pieces. When we call an API route with JSON, we have to set the HTTP method, set the content type, and manually stringify the body. So now I will send the post request. Await fetch, the URL is /API/posts, and the options will be method post. Now I will add the headers object into the options as well. Headers, content type, application, JSON. And now I will add the body as JSON. Body, JSON.stringify, and I will pass the title property. After the request completes, the server has the new post, but our UI still doesn't. So we have to manually refresh the list. So now I will call fetch posts again. Await fetch posts. Then I will clear the input, set title, and I will pass a blank string. And finally, I will turn off the saving flag. Set is saving, false. Now let's make the UI reflect these states. In the form, I want the submit button disabled while is saving is true. So I will update the button with a disabled prop. And to make the loading state obvious, I will render a small message when is loading is true. I will add a paragraph above the list. Now we can do a quick sanity check. If we run npm run dev, refresh the page, and submit a new post, the request goes to app/api/post/route.js. The server updates app/lib/posts-store.js, and then the UI fetches the updated list again. And this is the exact reason server actions exist. Look at what we had to do for one tiny form. We created a server endpoint file, we wrote client fetch code with method and headers, we tracked loading and saving state, and we manually refetched to keep the UI in sync. This baseline works, and it's a valid tool as well. But the hidden cost is all the extra plumbing you have to keep repeating for every small mutation, especially when the action is internal to the app and only triggered by the UI. In the last section, we did the classic thing. We created a route handler and we called it with fetch. It works, but even for one small form, we immediately ended up with more files, more moving parts, and a bunch of things we had to remember every single time. So now, let's talk about the mental model shift that Next.js is pushing you toward in the app router. We can often think like this: I need to run a server-side function when the user clicks or submits. In Next.js, that server-side function has a name, a server function. It's an async function that runs on the server, and when the client calls it, Next.js triggers a network request behind the scenes. That's also why it must be async. And here's the important detail. When we use a server function in a mutation context, like create, update, delete, people usually call it a server action. So, server action isn't a totally separate feature. It's basically a server function being used to change data. Also, don't let it feel magical. Even though we call it like a normal function, it's still HTTP under the hood. In fact, actions are invoked using post, and only post can trigger them. One more rule we need to lock in right now. We will use actions mainly for mutations, not reads. If you are trying to read data, you typically want server components and normal server-side data fetching. Calling a server action to read data often just adds an extra hop. Alright, let's make this real with code. We already have a server-side store in app/lib/posts-store.js, and we already have a UI in app/posts-demo.js. Now, we will add a server action file that can create a post directly on the server without us manually constructing a fetch call with headers and JSON. Let's create a new file called app/actions.js. The first line is the directive that marks this file as server only. Use server. Now, I will import the server-side function we want to use. Import create post from lib/posts-store. Next, I'll write the action function signature first. Export async function create post action, and I will receive the title. Inside, I will call create post with the title and store the result. And then I will return that post. This is the part that feels like a normal function call from the client, even though it's still a server round trip. Now, let's switch back to app/posts-demo.js. We already have a submit handler that does a post request to /API/posts. We are going to replace that request with a direct call to our server action. First, down in handle submit, I'm going to remove the fetch call. In its place, I will call our action and capture the created post. Const created post is equal to await create post action, and we will pass the title. Nice. My editor auto imported it at the top. Now, we want the UI to update immediately with the newly created post. Before I type this next line, here's the idea. Instead of refetching the entire list, we can take the post the server just returned and put it at the top of our local post state. So, I will update the post state using the function form. So, we always work with the latest array. Set posts, I will receive the previous posts as in parameter, and then I will return a new array, pass the created post, and previous posts spread it. And now that the UI is updated, we can remove the manual refetch. So this line is going away. Await fetch posts. Everything else stays the same. We clear the input and we set isSaving back to false. At this point, if we refresh the page, it still loads the initial list by calling get API/posts. But when we submit the form, we are no longer manually creating a post request ourselves. We are calling create post action function just like a normal function, and Next.js handles the server trip for us. So that's the real mental model. With route handlers, you design an HTTP interface, request in, response out. With server actions, you design a function interface, call a function, get a return value, while Next.js quietly does the HTTP work under the hood. And remember the boundary we set. We will use this mainly for mutations. Reads belong in server-side data fetching, not call a server action to read. In the last section, we built the baseline, a route handler, and a client-side fetch call that submits JSON. it works, but you can already feel how many things you end up wearing together just to create one single post. Now, I want to show the first real win with server actions, and it's the most natural place to start. A plain HTML form. Instead of saying when the user submits call fetch, we can say something simpler. When the user submits, run this server-side function. And when we do that through the action prop, React gives that function a form data object automatically. Let's open app/page.js. And for this section, I want this page to be our simple post screen. A heading, a form, and a list. First, I will import the two server-side helpers we already have, create post and get post. Inside page, I'm going to define a server action right here. The reason I'm doing it inline is so you can clearly see the relationship between the form and the code that handles its submission. I'll write the function signature first. Async function, create post form, and I will pass the form data. Now, I will mark it as server only using the directive useServer. When a function is used as a form action, React hands us form data. And the key thing to remember is inputs become available through their name attributes. So first, I will read the title field. Const title is equal to formData.get title. Now, I will create the post on the server using our store function. Create post, and I will pass the title. Now, quick note for larger forms. You can pull everything into an object with object.fromEntries and by passing form data. If you ever log that object, you might notice extra keys that start with $action _. So treat it as raw input and only pick the fields you need. Now let's render the page UI. I will start the return and put a main tag first. Inside main, I will add a heading, beyond components. Next, I will add a short sentence so the learner knows what we are testing. In this section, our form will call a server action directly. Now I will add the form tags. And this is the key line. I will pass the server function to the form's action prop. Inside the form, I will add an input first. Now, I will give it a name of title because that's what we read on the server with formData.get title. And I will make it required. So the browser helps a bit before the submit even reaches the server. Now, I will add the submit button. Great. Now we need to render the list of posts from the server store. Before the return, I will read the posts. Const posts is equal to get posts. Now, under the form, I will add a UL. And inside, I will map over posts. Now, I will render an li with a key and the title. At this point, if we run npm run dev, type a title, and submit, we are not doing any manual JSON, no fetch, no client-side submit handler. It's still a normal form submission, but the server-side mutation logic is sitting right next to the UI that triggers it. And there's one more quiet win here. This is progressively enhanced by default. Even if JavaScript is slow to load or disabled, a form submit can still reach the server. The action can still run and the page can still come back updated. Now let's test this. So far, everything looks like it's working, right? Now I will create another post. I type another post and click add post. Boom, the post was created, but the UI didn't update. If I manually refresh the browser, the post suddenly appears. So what just happened? This isn't a server actions bug. What's happening is that the page is still rendering cached output. So even though the mutation succeeded, the UI is showing stale data. And this is important. This doesn't happen all the time. But when your UI is rendered from cached server output and it stays stale after a mutation, this is exactly what it looks like. So in cases like this, after the mutation, we need to tell Next.js, this route is stale. Please render it again with fresh data. That's what revalidate path is for. Since our post list lives on the root route, we will revalidate the root route. Right after create post, we add revalidate path and we will pass the root route. Now we go back to the browser. Once again, I type another post and click add post. This time it works. The post shows up immediately. If your mutation succeeds but the UI stays stale, it's usually a caching thing. Revalidating the route tells Next.js to re-render with fresh output. Right now, our form works. But works isn't the bar for a real app. The moment you have any latency, slow Wi-Fi, a busy server, a mobile device, the user clicks add post and nothing. No feedback, no disable button, no clue if it's submitted or if they should click again. And that's how you get double submits and weird bugs that look like Next.js is broken, when it's really just missing the UI feedback. So in this section, we will do one simple thing. When the form is submitting, we will show a pending state and disable the submit button. And we will do it in a way that matches how React wants forms to work in modern Next.js, without building our own fetch state machine. To make the pending state visible while we test, I'm going to add a tiny delay inside our server action. Not because your app should be slow, but because it helps us see the pending UI clearly. Let's open app/page.js. Inside our create post form action, right after use server, I will add an await delay. Before I type it, here's why it looks like this. We need a promise that resolves after a timeout, so the action stays in flight for a moment. Await, new promise, I will get the resolve, and I will return set timeout, resolve, and 800 millisecond. Now, let's add the pending button UI. The hook for this is use form status, and it lives in React DOM. The important rule is use form status can only be used in a client component. So, our submit button needs to be its own small client component. Let's create a new file called app/submit-button.js. First, I will add the client directive, use client. Now, I will import use form status. Next, I will write the component signature first. Export default function submit button. Inside, I will call use form status. In React 19, the returned object includes more than just pending, but for now, we only care about the pending property. Const status is equal to use form status. Now, I will return a button. First, the tags. Button type submit. Next, I will disable it while the form is pending. Now, I will put the label. If it's pending, we will say adding, otherwise add post. Cool. Now we need to use this button inside the form. Back in app/page.js, inside the form, I'm going to replace the current button with our new submit button component. First, I will type the component where the button was. Nice. My editor auto-imported it at the top. Now we can test. Run npm run dev, submit the form, and because of the small delay, you should see the button switch to adding and become disabled until the request finishes. And this is the kind of UX rule we want to keep for every mutation in this course. When something is in progress, the UI should say so, and it should make it hard to accidentally do the same action twice. One more subtle detail to keep in mind. This form is still a real form submission. Even before JavaScript is ready, it can submit. And after hydration, Next.js will handle it without a full page refresh. But the user still gets a clean pending signal either way. Our form already submits and creates a post. But right now, if the user submits bad input, we don't have a clear plan for what happens. Maybe the title is empty, maybe it's just spaces, maybe it's way too long. In real apps, if you don't handle this, you end up with messy data and confusing UX. So, in this section, we will add server-side validation and show real errors in the UI, field by field, without changing the whole app structure. We already added required on the input, and that's a good baseline. But that's only client-side validation. The server must still validate because the server is the one that actually writes data. For server-side validation, we will use Zot. If you haven't installed it yet, run this once. npm install Zot. Now, let's build a server action that validates and returns a predictable error chef. Create a new file called app/posts-action.js. First, I will mark it as server only. Use server. Now, I will import Z from Zod. And I will import create post from our store. Next, I will define a schema for the form data. I will write the constant first. Constant create post schema is equal to z.object, and I will pass the object for taking any options. Now, I will add the title field. I want to trim it, require at least one character, and also cap the length so the UI doesn't get weird with a massive string. z.string.trim.min, at least one character, title is required, .max 80, and title is too long. Now, I'll write the action function signature. This is important. When we use useAction state, the action receives the previous state as the first argument and the form data as the second argument. Inside, we will convert the form data into a plain object. For bigger forms, object.formEntries is the easiest way to pull everything out at once. Just remember, it may include extra $action_ keys. So, validation should only pick the fields you care about. Const raw is equal to object.formEntries form data. Now I will validate with safe parse. So we get a success flag instead of throwing. Const result is equal to create post schema dot safe parse, and I will pass raw. If the validation fails, I want to return early with a consistent shape the UI can render. Now I will flatten the errors so we can get field level messages. Const field errors is equal to result.error.flatten.fieldErrors. And I will return a simple state object. I am going to keep a message and a field errors object with a title string. If validation passes, we can create the post using the validated title. And we will return a success state with no field errors. Great. Now we need the UI to actually show these errors. And this is where useAction state fits perfectly. We can't call useAction state in app/page.js because it's a server component by default. So we will move just the form into a small client component and keep the post list on the server. Let's create a new file called app/createPostForm.js. First, I will mark it as a client component. Now, I will import useAction state from React. Next, I will import our server action. Import createPostAction posts-actions. And I will import our existing submit button because it already handles the pending state with useFormStatus. Now I will define the initial state. I will write the constant first. Const initial state is equal to an object with a message and field errors as properties. Now I will write the component signature. Export default function create post form. Inside I will call useAction state. It returns the current state, a form action function we can pass to the form, and a pending boolean. Now I will return the form tags first. Inside the form, I will add the input. And I will disable the input while pending is true, so the form feels stable during the submit. Now I will render the field error right under the input. If there's an error, we will show it as a short message. Now I will add the submit button component. And finally, I will add a message area under the form. Area live is equal to polite helps screen readers announce updates without being too aggressive. Cool. Now we need to use this new form component in app/page.js. Open app/page.js. At the top, I will import create post form. And inside the JSX, where the old form was, I will render our component instead. Now do a quick run. Submit an empty title, and you should see the field error. Submit a valid title, and you should see the success message. And because the list is rendered on the server, you should also see the new post appear. And that's the core pattern. Validate on the server, return early on invalid data, and always return a state shape that the UI can render predictably. Our form is in a good place now. It submits through a server action, we have pending UI, and we have server-side validation that returns real field errors. Now the moment we move from create a post to manage post in a list, a few practical problems show up. How do you edit one specific post inside a list? How do we delete a post from the same row? And how do we pass the post ID safely without sticking it in a hidden input and hoping nobody tampers with it? So, in this section, we will build a pattern you can reuse everywhere. Each row has its own small form. We bind the post ID into the action, and we use form action to support multiple submission types from inside the same form. Let's start on the server. Open posts-store.js. We already have get posts and create post. Now we need an update and a delete operation. First, I will add a function for updating a post title. Export function update post title, and we will receive post ID and title. Inside, I will replace the matching post by ID and keep everything else the same. Post is equal to posts.map. We will receive each post and then return post.id, and we will return if post.id is equal to post id, then we will return post title, otherwise post. Now I will add the delete function. Again, the signature first. Export function delete post, and we will receive the post id. Inside, I will filter it out by id. Posts is equal to posts.filter. We will receive each post and then return if post.id not equal post id. Cool. Now let's create the server actions for these list mutations. Open app/posts-actions.js. At the top, we are already importing create post. Now I will update that import to also include the new store functions. Import delete post, update post title from lib/posts-store. Now let's add an update action. When a function is used as a form action, it receives form data. And when we use bind, we can pass extra arguments like the post id without putting that id into the HTML. I'll write the function signature first. Export async function update post title action and receive post id and form data as parameters. Inside, I will pull the raw fields out. For bigger forms, object.formEntries is the easiest way to get a plain object. Const raw is equal to object.formEntries, and we will pass the form data. Now, I will validate the title using the same schema we already have. Const result is equal to create post schema dot save parse, and we will pass raw. If validation fails, we will just return early. In the next section, we will talk about keeping UI in sync more reliably, but for now, the important part is the server still validates. Now we can update the title. Update post title, and we will pass post id and result.data.title. Next, the delete action. Signature first. Export async function delete post action, and we will receive the post id. And inside, we delete by id. So call delete post, and we will pass the post id. Awesome. Next, let's make the UI match this reality. List rows need to edit and delete. Open app/page.js. Right now, we render each post as a plain li. We are going to turn each row into a form. First, at the top, I will import the two actions we just created. Delete post action, update post title action. Now, I want the title input to support a keyboard shortcut. Ctrl+Enter on Windows or Linux, or Command+Enter on macOS. To do that, we need a small client component for the input. Create a new file called app/post-title-input.js. First, I will mark it as a client component. Now, I will write the component signature first. I will accept props so this input stays reusable. Export default function post-title input, and I will receive the props. Inside, I will write the keydown handler signature first. Before I type the condition, here's what we want. If the user holds Ctrl or Command and presses Enter, we don't want a new line or any default behavior. We want to submit the nearest parent form. So now I will write the condition. If e.control key or e.meta key, and if e.key is equal to enter or e.key is equal to numpad enter. Inside that block, first I will prevent the default. So e.prevent default. And then I will submit the closest form using request submit. That method triggers a real form submission, which means it will correctly invoke our form action. e.currentTarget.form. I will use optional chaining .request submit. Now I will return an input. First the tag, then I will spread the props onto it and attach our keydown handler. Cool. Back in app/page.js, I will import this component. Now let's update the list. Inside the map, instead of a plain li title, we will render a form for that post. First, I will keep the li key post id wrapper. Inside that li, I will add a form. Now, I will bind the update action with the post id and pass it as the form action. This is the safe id passing rule. The id comes from our data, not from user input. Inside the form, I will add the input. I want it to start with the post's current title, so I will use default value. Now I will add a save button. Now comes the multiple action part. I want a delete button in the same row, but it should call a different action. That's exactly what form action is for. So I will add another submit button and I will override the action with the delete action bound to the same post ID. So form action is equal to delete post action dot bind. I will pass null as this keyword and post ID. At this point, we have one form per row and two submission types in the same form. Save updates the title using the form's action and delete overrides the action using form action. Now, there's one more place where the keyboard shortcut is useful. The create form at the top. That file is already a client component. So we can add the same behavior there too. Open app/createPostForm.js. Above the return, I will add a key down handler. Signature first. Handle title key down is equal to I will receive the event and return something. And now the same condition. Control or command plus enter. Now I will attach it to the input by adding on key down. So on key down is equal to handle title key down. Now do a quick run. Edit a title and hit save. Hit delete to remove a row. And in the create input, try command plus enter or control plus enter to submit without moving your hands to the mouse. And that's the advanced pattern in a nutshell. Use one form per row, pass IDs with bind, use form action for multiple submission types, and use request submit for power user keyboard flows. At this point, we can create, edit, and delete posts. But there's a question that always comes up in real projects right after you ship the first mutation. I changed the data. Why didn't my UI update? This is where you need to understand what Next.js is doing for you and what you still need to do explicitly. When you mutate data with a server action, Next.js can re-render UI from the server in the same round trip. But caching is still real. If a part of your UI is cached, Next.js won't magically guess which screens should be refreshed after a mutation. So in this section, we will lock in a simple rule. After a mutation, you either revalidate the right cache keys, or you refresh the current route, or you redirect to a new route. Sometimes you do more than one, but the order matters. Let's start with revalidation because it's the most common why didn't it update fix. Open app/postsaction.js. We are going to import revalidate path so our actions can tell Next.js which screen needs fresh data after a mutation. First, I will import revalidate path from next cache. Now, we will update the create action. On success, we want to create the post. Then revalidate the home page list. Right after create post, I am going to capture the return post. Now, I will revalidate the home page path. Revalidate path and I will pass the home route. And then I will return the success state like before. Return an object, message, post added, and field errors title. Now, let's do the same for updates. In update post title action, after we update, we should revalidate the home page list. So, revalidate path, home route. And for deletes, after we delete, we should also revalidate the home page list. So, revalidate path is used also here. Now, revalidation is about making sure the server rendered parts of your app don't keep showing stale cache data. But there's another tool people reach for, refresh. To demonstrate refresh, let's add a small refresh button on the page. This doesn't replace validation and it doesn't revalidate tagged caches, but it's a useful escape hatch when you want to re-render the current route from the server. Create a new file called app/refreshbutton.js. First, it needs to be a client component. Now, I will import useRouter from Next navigation. Next, I will write the component signature first. Export default function refresh button. Inside, I will get the router. Const router is equal to useRouter. Now, I will return a button. First, the tags. And now, I will attach the click handler that calls router.refresh. Before I type it, the key idea is this asks Next.js to re-render the current route from the server so you see the latest state. So, button type is equal to button. So, onClick is equal to router.refresh. Cool. Now open app/page.js and import it. Import refresh button from refresh button. And I will render it near the top of the page, right under the create form. Now, let's talk about redirects. After creating a resource, it's common to navigate to that new resource page. The important detail is that redirect is not a normal function return. It throws a control flow exception that Next.js catches and turns into a redirect response. That means any code after redirect will not run. So if you need to revalidate, do it before redirecting. To make this real, let's add a post details page. First, open app/lib/posts-store.js and add a helper to fetch one post by ID. I'll write the function signature first. Export function getPostById and we will receive the ID here. Inside, I will find it. Return posts.find. We will get each post and then return if post.id is equal to id or null. Now, create a new file at app/post/id/page.js. First, I will import getPostById. Now, I will write the page function signature first. Export default async function post page and we will receive the params. Inside, I will read the ID from params. So, const ID is equal to await params. Now, I will load the post. So, const post is equal to getPostById and I will pass the ID. If it's missing, we will show a simple message. If not post, return post not found. And if it exists, we will render the title and a backlink. Now, we can update the create action so that on success, it redirects to the newly created post page. Back in app/posts-actions.js, first I will import redirect. Now, in the create action, right after we revalidate, I will redirect to the new route. Redirect/posts, post.id. Now the last piece, cookies. Sometimes, after a mutation, you want to update a preference or store a small server-side flag, and then you want the UI to reflect that immediately. In Next.js, when you update cookies inside a server function, Next.js will re-render the current server component tree while keeping client state intact. That makes it a surprisingly clean way to keep server visible state in sync. Let's store the last created title in a cookie and show it on the home page. Back in app/posts-actions.js, I will import the cookies. Now, inside the create action, right before we redirect, I will grab the cookie store. And I will set a cookie with the title. Cookie-store.set last created title. That's the name I gave the cookie. And post.title. Now, open app/page.js. We will read that cookie and show it. First, I will import cookies. And because cookies function is async here, I will make page async. Export default async function page. Inside, before the return, I will read the cookie value. So, const cookie store is equal to await cookies. Now I will grab the value out. Const last created title is equal to cookie store.get last created title optional chaining dot value or blank. And in the JSX, under the create form, I will show it if it exists. So, last created title, logical and last created, and I will get the last created title here. Now, do a quick run. Create a post, and you should be redirected to /posts/id. Click back, and you should see the list updated, plus the last created message pulled from the cookies. So, when you ship a mutation, the mental checklist becomes simple. If a server-rendered screen might be cached, revalidate the right path or tag. If you just need a fresh render of the current route, refresh. If you need to navigate, redirect. And remember, that code after redirect won't run. And if you update cookies, Next.js will re-render the server tree so your UI can reflect that change immediately. By now, we have gotten a lot of mileage out of server actions. Our mutations sit close to the UI that triggers them. Pending states feel natural, validation lives on the server, and we are not writing bunch of manual fetch code for every submit. Now, we need to do something that's honestly more important than the feature itself. We need to learn where the edges are. Because if you try to use server actions for everything, you will eventually end up fighting the framework. And if you ignore server actions completely, you will keep paying a mini API tax for simple internal mutations. So here's the boundary we will follow. If it's an internal UI-triggered mutation, like create a post, update a title, delete a post, server actions are usually the best fit. If it's an externally consumed endpoint, like webhooks, public APIs, streaming responses, or anything that needs low-level HTTP control, route handlers are the better tool. Let's make this concrete by adding 3 endpoints to our app. None of these are meant to be called from our UI directly. These are endpoints that exist because something outside the page needs to talk to our server. First, let's add a public read endpoint that returns posts as JSON. This is not a mutation and it's not tied to a form submit. So a server action is the wrong shape. Create app/api/public/posts/route.js. First, I will import get posts. Now I will add the get handler signature. And inside I will return JSON. Now anyone can call get API/public/posts from outside the app. And that's the key difference. This endpoint is designed to be consumed externally, so it should be an HTTP interface. Next, let's add a webhook endpoint. This is the classic case where server actions aren't the right tool because the caller is not your React component. It's a third-party service. Create app/api/webhooks/demo/route.js. First, I will read the webhook secret from an environment variable. Const webhook secret is equal to process.env, and we can name the environment variable demo_webhook_secret. And for a quick sanity check, and we can use the blank if it's not there in the environment file. Now I will add the post handler signature. Export async function post and we will receive the request. Before I read the body, here's the idea. Webhook providers usually sign the request. That means we must look at headers and we often need the raw body to verify the signature. So first, I will read a signature header. Const signature is equal to request.headers.get and maybe the header name is xdemo signature. And a quick sanity. Now, I will read the raw text body. Const raw body is equal to await request.text. Now, I will do a tiny demo verification. In a real webhook, you would compute an HMSC and compare signatures. Here, we will just compare the header to the secret so the endpoint stays runnable. So, I will write if not webhook secret or signature not is equal to webhook secret, then return new response invalid signature and pass the status 401. Now, we can accept the event. Console.log webhook received and the webhook is raw body. Now we will respond with a 200 status so the sender knows it was accepted. Return new response OK. This is exactly why route handlers exist. Webhooks are pure HTTP, headers, raw body, status codes, retries and external callers. Now the last boundary, streaming. This is the AI chat shape where you want to send chunks as they become available. Server actions are invoked with post under the hood and they are great for mutations, but they are not meant to stream a response chunk by chunk to the browser. Route handlers can do that. Create app/api/stream/demo/route.js. First, I will add the get handler signature. Inside, I will create a text encoder so we can enqueue bytes. Const encoder is equal to new text encoder. Now, I will create a readable stream. The important bit is that we can enqueue multiple chunks over time. To keep it runnable and easy to use, I will enqueue 3 chunks with a small delay. Then I will schedule the second chunk. Set timeout, controller.enqueue, encoder.encode, chunk 2 and a new line, and the third chunk, and then close the stream. Finally, I will return a response that uses this stream as the body. Return new response, stream, and the headers, content type text plain, and the character set UTF-8. Now you can hit get API stream demo and watch the text arrive progressively. So that's the boundary map. If it's a UI triggered internal mutation, reach for a server action. If it's a public endpoint, a webhook, a streaming response, or anything where you care about raw headers and protocol level behavior, reach for a route handler. And one last reminder from earlier, don't use server actions for reads. Reads belong in server-side data fetching, and if something must be read by an external consumer, expose it as a route handler. Up to now, we have been using forms as mutation tools. Create, update, delete. That's the sweet spot for server actions. But not every form is a mutation. Sometimes your form is really just navigation. A search box is the classic example. You type a query, submit, and you want the URL to update with search params like query is equal to React. Then the page loads results based on that URL. If you build that with a server action, you are using a mutation tool for a navigation problem, and it usually becomes more complicated than it needs to be. This is exactly what Next form gives you. It's a form component that extends the native HTML form for navigation style forms. If the action is a string, it behaves like a get form submission that navigates and updates search params. It also adds prefetching and client-side navigation so it feels fast. And if the action is a function, it behaves like a React form and executes a server action. Same component, two behaviors based on the type of action. Let's build a small search feature alongside our posts app so you can see this boundary clearly. First, create a new file, app/search/page.js. This page will read the query form, search params, and show it. I'll start by writing the function signature first. Export default async function search param, and I will receive the search params here. Inside, I will read the query out. In the app router, search params can be async, so I will await it. Now, I will normalize the query. If it's missing, we will use an empty string. Now, I will return a simple UI. First, the main tag. Inside, I will show a heading, search. And I will show what query we received. Query, colon, and the query. And I will add a link back to home. Now, let's add a search form to the homepage using Next form. Open app/page.js. First, I will import form from Next form. Now, inside the JSX, above the create post form, I will add the form tags. Now, I will set the action to the string route search. This means this form behaves like a get form that navigates to /search and appends the input values as search params. Inside the form, I will add an input first. Now, I will give it a name of query. So it becomes query is equal to in the URL. And I will add a submit button. Now, let's add a pending indicator to this navigation form. For this, we can still use form status, but remember, it must be in a client component. Create a new file app/search-button.js. First, mark it as a client component. Now, import useFormStatus. Now, write the component signature. Inside, call the hook, const status is equal to useFormStatus, and return the button. First, the tags. Now, set the label based on status.pending. If status.pending, then searching, otherwise search. Cool. Now back in app/page.js. Inside the form, I will replace the plain button with search button. First, I will type it in. Nice. My editor auto-imported it at the top. Now, let's do a quick run. Type a query, submit, and you should navigate to /search and the query is passed using client-side navigation. And if shared UI wasn't prefetched yet, you still get the searching feedback instantly. Now the final boundary note. Form has caveats. It's intentionally focused on navigation behavior. If you try to use props like method, entype, or target, it won't support them because those override its behavior. And if you use onSubmit and call prevent default, you override the navigation behavior too. And one more subtle point. For mutation forms where the destination depends on a redirect inside the action, form can't prefetch because it doesn't know the destination until the action returns. That's normal. So this is the clean separation. Navigation style forms use Next form with a string action, and mutation style forms use server actions with a function action. You just learned how to handle mutations in Next.js without the route handler headache. We moved from manual fetch calls to native forms that submit with form data, validated input on the server with sort, and wired up the clean pending states using useFormStatus so the app feels solid even on a slow network. Now let me tell you the big picture. But the real win here isn't just a shorter code snippet, it's confidence. You can know how to keep your UI in sync after the server changes, how to handle field level error predictably, and where server actions fit into a modern full stack workflow.
You have effectively turned your front-end components into direct bridges to your database. So what's the next steps? For your next challenge, try attending this posts app with an edit flow or a tag filter navigable through search params. If this made server actions finally click for you, let me know in the comments. Are you officially team no more API doubts? Thanks for watching, and I will see you in the next one.